All right, let's kick this off. Welcome to Knative, Scaling from Zero to Infinity session. This is Thursday, the last day of the session, so hopefully, thanks for coming, and hopefully we have enough room for everybody here. Quick intros.
Hey, my name is Joe Burnett. I work on Google App Engine, and I'm the autoscaling working group lead for Knative.
And my name is Chmarny. I'm one of the technical program managers at Google, working specifically on serverless on top of Kubernetes. So, like I said, this is the fourth day. We already had, I think, 11 sessions, depending if you count some of the offsites or not. So hopefully you have got some of the introductory information about Knative. If you haven't, we'll capture this little in following slides. There are still 2 other sessions today. So this is total of 13, which is in itself a very amazing thing, given that this project just launched 4 months ago. So if you haven't attended any one of those Birds of Feather sessions, please do. Just a quick recap. If you haven't made to those previous sessions or you haven't heard about Knative before, we try to shove everything in on one slide, so hopefully it's not overwhelming. But Knative is a set of low-level components that address many of the common concerns when you're building a serverless application on top of Kubernetes. It solves for modern application patterns, so it doesn't try to kind of go after the stateful workloads, but more kind of stateless. And it is very much the set of ingredients for what you would need if you were to build serverless application on top of Kubernetes. Implements many of the learnings from Google and the partners, so there's a lot of goodness there. At the core, there's 3 things we would like you to walk away knowing about Knative. It's simple to start with. A lot of emphasis have been placed on kind of obfuscating the complexity of Kubernetes itself. There's a lot of things that happen for you automatically, including autoscaling, which we're going to be talking about today. And on the end of the day, there's a lot of different platforms that you've used before that were super simple for the Hello World example. But then, day 2, day 100 start, and you have kind of limitations. We wanted to make sure that it's very extensible. There's a couple additional links. We'll have more about the information and the different places where you can find additional data about that. So let's go into this. I think for the purposes of kind of level setting with everybody to the same, we're going to capture very quickly the kind of principal objects that are implemented in Knative. There's a configuration that represents a set of the state of your application, both the code as well as the configuration that you would deploy. We follow the 12-factor principle, separating the code and the application. There is a revision that represents a point-in-time snapshot of those 2, the code and configuration, that allow you to kind of roll back to and from if you wanted to. And there is a route which maps the traffic to a particular version of the revision. There's also a subset of these objects represented by service or K-service, as you might have seen some of this referred to on a conference here, that allows you to kind of manage these 3 principal objects in one construct, kind of high-level object. Today, however, we're going to go slightly lower than that. We're going to go into the pod autoscaler. So I want to ask Joe to maybe tell us a little more about that.
Sure. So the pod autoscaler is another custom resource, just like these other boxes here. It's an entity that you write to etcd, has its own controller. The pod autoscaler abstracts the autoscaling requirements and the autoscaling state of the revision. So for each revision, there's a pod autoscaler. And it gives us some really nice extensibility and control that I'll talk a little bit more in a minute.
Awesome. So if I went today, Joe, and downloaded Knative, or if I followed our GKE add-on, where with one click you can provide the actual entire instance of Knative, what type of capabilities would I get with regards to autoscaling out of the box, even there is no box really per se?
Sure. So out of the box, what you get with Knative is autoscaling by default. You get autoscaling based on requests. And a very fast autoscaling, so it responds within seconds. So this is pretty powerful, but it also scales to 0. So there's some orchestration that you get out of the box in order to scale to 0 when you don't need it and scale back. I'm going to show you some of that, but before I do, I want to give you a little bit of orientation to the screen that we're going to be looking at. This is an intermediate session, so of course it has command line. Can everyone see this okay?
Joe took in a challenge of showing as many panels of console as physically possible. So
that's right. More content, more panels. OK. So this is a service. This is what Mark was talking about, that top level box where you just basically give it a container, describe how you want to run it, and how you want to roll it out. I have another panel that I'm going to be showing you. Looks like this. On the upper left-hand corner, there are all the pod autoscalers that are deployed in this cluster. So right now there's one pod autoscaler, which means there was one revision. It's currently not getting any traffic. And so, as you can see on the right-hand side, there are no pods. Okay? This thing's ready to serve traffic. The revision's ready, but there's no pods around. Okay? So what I'm going to do is I'm going to take you over here, and I'm going to hit this application. So I've got this wired up to a custom domain. You can see how to do this in many of the Knative documentation. I'm going to hit it with a request. Oh, it's up already. OK. I think Google fired off a request before I even hit it. So there's a pod now. So this thing scales from 0, and it will go away again if I stop sending traffic. So this is pretty powerful, actually. You don't have to worry about what happens after you're done with something. Just take traffic away from it, and it'll get garbage collected on its own. So as I go through this demo, I want to try to fulfill a promise, which is that Knative comes with what you need out of the box to get started, but Knative autoscaling will grow with you as your service grows. That means that you're not going to have to suddenly hit a point where you retool and rebuild everything. Knative autoscaling will allow you to address your new and evolving requirements. So in order to keep it real, what I'm going to do is I'm going to start a little bit of load against this revision. I'm going to send it traffic through the whole demo as I evolve this application through the various autoscaling configurations. And so you will get to see that this thing actually still continues to work and serve customers even as we get into some more advanced autoscaling modes. So I'm going to say go run load. What this is going to do is it's going to start 16 processes making continuous requests against this revision. I happened to catch it right when it was trying to scale down. So one pod's going down, one pod's coming back up again. You'll see that the last response here, always, how many requests have been made. Each one consumes a little bit of CPU. OK, so here's my load generator. Now I'm going to show you what it looks like when you roll out a new revision. OK, so here is my service again. And I'm going to change a few things about this. This is the first customization that I'm going to do. Suppose that my service has a whole bunch of startup latency. Like it needs to do some pre-processing when it first starts up. And I don't want I don't actually want to scale to 0. I can actually specify min scale 0 and tell it to stick around. And I can adjust the autoscaling target as well. So let's say I want a target of 2. 2 what? So autoscaling, Knative autoscaling is based on concurrency. So that's the number of requests that are in flight per pod. So the cluster that I deployed here has a default of 10. So for each pod, it's trying to keep 10 requests going on that pod at any given time. So if traffic increases, you get more pod. If latency increases, you get more pods. But that seems to be a little bit too heavy for my application. So I want to bring that target down to just 2. OK? So here, I'm going to deploy a new revision. I'm going to call it KubeCon 2. So you can see the change here on this screen. You're going to see that it rolls out a new revision. Oh, one thing I forgot to tell you is that service YAML, I have a little script that just watches it and applies it every time I edit it. So you'll see me make changes. I'm just hitting save, and then it gets applied. And you can see it rolled out a new revision here. You can see it's serving the new data, right? It's giving me KubeCon 2. The old one is still there. It even has a pod running still, because it hasn't gone away entirely. But there's more pods. So previously, we had 16 requesters, targeting concurrency of 10, rounds out to about 2 pods. Now I said, OK, actually, I want 2 requests per pod, so that comes out to about 8 or 9 pods. So that's sort of the basic autoscaling that you get out of the box.
Nice. So Joe has showed us the default autoscaling strategy in Knative, which is based on requests per second rather than utilization. It showed us some configuration capabilities that are available in a manifest for service itself that allow us to define the minimum, the maximum, the explicit target, and other capabilities therein. But how about what are type of strategies that are included with Knative that I can easily switch to? For example, can I go back to the standard CPU-based autoscaler that we are used to with Kubernetes?
I'm glad you asked that question. Yes.
It's almost as we were scripting.
Yes, you can. So the pod autoscaler there is a resource that actually has 2 controllers in Knative. And if you want to change the strategy, you can actually select a different controller. If you want to go back to CPU-based autoscaling, maybe you just want to, maybe your service doesn't need to scale on request, maybe it's just CPU-bound, you could do that. So I'm going to show you how. Over here, I'm actually going to change the metric to target CPU. And as I mentioned, this is actually implemented by a different controller. So I actually specify class. Now, what the controllers do is they select on class to decide which pod autoscalers they should operate on. So instead of the default KPA, or Knative autoscaler, I'm going to go with an HPA. Make sure I spelled that right. OK, so I'm selecting the HPA class. I'm going to say this is our CPU-based one. And I'm going to show you one more cool feature about the service YAMLs. You can roll things out in an incremental fashion. So going from concurrency-based autoscaling to CPU-based autoscaling maybe is a little bit hairy. So I want to do this a little bit at a time. So I'm going to roll it out to 50% and kind of make sure it's OK before I can continue, right? This is how we actually release software in production. OK, so I'm going to save that again. It applied it. Let's see what happens. Oh, we got a new revision. That's great. You can see there's one pod. You can see it's serving about 50% of the traffic here. OK, and I'm going to show you something that it created. So as I said, this just uses the regular Kubernetes horizontal pod autoscaler. So I'm going to show you that there's an HPA that it turned around and created here and delegated to that. So this is using the normal Kubernetes autoscaling that you know and love. Yeah, so this looks good to me. So I'm actually going to go ahead and roll it out to 100%. Delete the old one. Go back to 0. It's not going to roll out a new revision because I only modified the traffic split. And we're on CPU-based autoscaling now.
Nice. So Joe has showed a lot of flexibility and control points that are already exposed to any developer solely through the manifest. This is a service manifest the developer applied a YAML file, applied and pushed it, which is great from a flexibility standpoint, but I could see the ops people going, whoa. So what are some of the operational controls that Knative provides in order to kind of have a little more of a boundary or control points that I can introduce to the deployment?
Sure. So it's true. Like eventually, you don't really want somebody just going and modifying production and rolling out arbitrary strategies.
No.
Knative addresses this in part by making revisions immutable. So revisions are immutable snapshots of the code plus the configuration. So every time you change something, it rolls out a new revision. So you can always roll back, right? It's really nice that way. But sometimes you don't necessarily want to roll out a new revision. Like, for example, maybe it's New Year's Eve, right? You have a very popular video and transcoding app, and you are running at 80% of your quota, and you realize that you need to change your autoscaling parameters. You need to tweak things a little bit. You don't want to roll out a new revision, right? It's 10 minutes before New Year's Eve. This is a bad idea. So maybe you would like to just reach under the hood and tweak some of the autoscaling parameters. This is another reason why it's useful to have the autoscaling state as a separate resource. The pod autoscaler is actually mutable. So you can actually ACL this down to your SRE org or whoever you think should have that power. And you can change the parameters in place, and they'll take effect immediately without necessarily rolling out a new version. So I'm going to show you what that looks like. I'm going to come back over here, but instead of changing the service, I'm going to go modify the revisions that exist already. So I'm going to just use kubectl edit, and I'm going to modify this second app. This is the one that I said don't scale to 0, but I want that quota back. So I'm going to tell it to just go ahead and scale to 0 by deleting that directive. Okay? And I'm also going to modify the CPU-based autoscaler. And I realized that even though we said infinity, infinity's not a good idea. So I'm going to go with max scale of 10. Okay? And I'm going to change the target a little bit. So target, means something different depending on what your metric is. So what I'm going to do is as soon as I save this, you're going to see those values propagate over here to the horizontal pod autoscaler. So I'll save this and apply it. And you can see now we're targeting 50% with a max pods of 10. No new revision, just kind of modifying things in place. And this works the same way for the Knative autoscaler as well. So yeah, you got the usual Kubernetes goodness for managing this resource. It's sort of, it's a more powerful resource that you can restrict access to.
Great. So we've seen the automatic autoscaling that basically comes out of the box, as we've been calling it now. You've seen a lot of control points where you can impact this yourself. We also have seen some guardrails you can define. Joe talked a little about the control organizational controls you can implement. On the end of the day, this is the autoscaler is implemented as a CRD, so you can apply RBAC rules to this that will be organization specific within your team. So that's all great. There's a lot of flexibility that's built in that the Knative team has envisioned you needing. But how about if I'm special, Joe? How about if I need something that the Knative team just possibly could not imagine? What are some of the options there for me?
You're right, Mark, you are special.
Oh, thank you.
So yeah, sometimes you need something entirely different. I don't know, maybe something we haven't thought about. That's the whole point, right, is to put these extension points in place so that you have an escape hatch. So as I said, we have 2 controllers that we've implemented for the pod autoscaler. You can make another controller that selects based on class. So as a demo of how easy that is to do, I've created my own controller. I call it the YOLO controller. Okay? And what this thing does, so just this is very simple for the purpose of this demo. If you actually want to do this in production, there's a nice example. There's a sample controller here that you can copy. I started with that. It just wasn't very good for the purpose of a demo because it was,
Too many lines.
Too many lines of code. This is like, 50 lines of code here. All right, so what it does is it establishes a watch on pod autoscalers, okay? So we can see changes to them. Selects just those that are annotated with YOLO, right? Those are my pod autoscalers, rather than KPA or HPA autoscaling native dev. It runs a very intelligent algorithm here called recommended scale, which does something. Okay? Maybe this reads from a database. Maybe it runs a machine learning algorithm. This is a controller running in your cluster, so you can give it permission to do what it needs to do. This is your control plane code, right? Then you just update the scale ref. That's part of the pod autoscaler, and update the status. So the one other signal you have to give is you have to say ready equals true, so that the higher level controllers, like the route controller, knows that it can send you traffic. So for example, the KPA checks to make sure the endpoints are there, make sure the pod actually started, and then it says, okay, I'm ready to go. So I'm going to deploy a YOLO revision. So don't worry about the metric. We don't need metrics. Okay? This is going to be YOLO.
Because you live only once.
That's right. Just go for it. As a matter of fact, we're going to go ahead and release it all at once. Because that's what this is. So I just deployed this thing. You can see there's a new revision here up and running. My controller has complete control over the pod autoscaler. I'm the one that decides the reason for the status, right? It just said, I'm ready to go. Didn't even matter, didn't even check the pods or anything. And it scaled to 2, right? And there it is. So now I'm serving YOLO. And just to kind of drive the point home, you can update the controller too. So I'm going to come back over here and I'm going to make my algorithm a little bit smarter.
Twice as smart.
Twice as smart, that's right. I mean, really, we know the answer is 42, but I don't want to tempt fate. Now I'm going to build my controller. Okay, so I'm going to run a tool called Co. And what Co does is it builds Go binaries in user space. It just looks in your YAML for something that looks like it's probably a Go binary, builds it, uploads it to your repository, gets the fully qualified hash, injects it back in, and then kubectl applies the thing. Just basically makes it easy to deploy stuff. So okay, I built this
I think I've seen the author of Co over there somewhere.
Oh yeah, I want to have words with you. It's awesome. It's one of these random things that came out of Matt Moore's brain. It's really cool if you happen to be using Go and you're using a lot of YAML. It makes things a little smoother. So here it is. It built, it deployed, uploaded, updated the deployment. Came over here. Hey, look, our algorithm has run. We've calculated we need 4 pods. Notice that it only touched the YOLO revision. And that's it. I mean, we're using my controller. If you choose that annotation, now you can mix and match here depending on what auto-scaling strategy you want for your service. And of course, you can roll back to.
Awesome. So Joe has showed a very simplistic algorithm, obviously hard-coded into the autoscaler. Knative autoscaler strategies are entirely based on metrics that come from the cluster itself. But in using this custom autoscaler, you can actually implement strategies that would be based on other variables outside of the cluster. Joe mentioned machine learning algorithm that might be using parameters or inputs that are from some gateway upstream, or even some use cases where you have n number of microservices that implement a pipeline, and maybe the one downstream needs to be scaled based on the input from the further upstream. So a lot of different variables and customizations you can do there. Great. Any other?
No, just yeah, we want to make sure that we get out of your way and you can do what you want to do.
So hopefully we've showed you at least a few ways you can kind of customize the auto-scaling strategy inside of Knative. We've put up a number of different links and documentation. Joe also provided every single sample that you've seen during the demo today on his repo. We have ability to both follow the instructions for installing Knative itself by yourself on a Kubernetes cluster in our repository. We also have a GKE add-on that it's now available on GCP, on Google Cloud, that you can kind of subscribe to and just with a single command provide a fully configured and validated cluster. We also have active Slack channels, including one dedicated to autoscaling. So if you want to learn more about it, then ask the people who actually work on this from the broader community. This is a good place to ask. Anything else, just ping me on Twitter, and we love to talk. Well, I think we can open up. I think we have another 3-4 minutes. If anybody has a question, there's a question.
The question about the annotation. So as far as that is following the pattern of ingress, which is both pattern and anti-pattern in some way that how do you make sure that you don't get the explosion of annotations as it happened with ingress annotations
Can you repeat the question?
Yeah, sure. So the question was, is this following the pattern of ingress? Yes, it is. Ingress has a problem, which is it has an explosion of annotations. I think this could have the same problem. I don't know if I have an answer other than, yeah, we need to make sure that we manage that. We've fully qualified the class, so that you don't have collisions there. And I think all the other annotations can just be per class. I've tried to make them consistent within Knative, but if you have thoughts on how to contain that, please do tell me, because I'm sure I'll run into the same problem. Yeah, here in the front.
First of all, this is very cool. Is anything using in production? Are you aware of any production use cases?
The question was, are we aware of any production
Yeah,
this?
The session before this one by T-Mobile showed, I don't have intimate knowledge how they deploy in production or anything, but showed a store locator application that's definitely some portion of that running in production. I think the IBM team has something out there too. I think in a channel, there's a couple of examples there people listed too. I don't have as good of a knowledge outside of Google, but yeah.
Not enough though. I mean, part of
it's still early days, yeah.
One of the reasons why I've been focusing on this extensibility is because if concurrency-based autoscaling doesn't pan out, I don't want anyone in production to be stuck. So I want you to be able to sort of tweak the necessary parameters to make it work for you. So yeah, we really need a lot more production experience. So I encourage you to try it. Tell me what you think. Give us some feedback, and if there's anything missing, tell us about your use cases.
And this might be a great point. Even if you're not a developer and you are working on a specific use case that it's not addressable currently, just please go into GitHub, submit a issue. It doesn't have to be sampled with code or anything like this. Just tell us what's missing, and that's the only way Knative is going to get better.
Other questions? So I have two here in the front.
Do you have any examples of latency-based scaling?
Latency-based scaling. I don't have examples of it. The concurrency-based scaling does take latency into account because, of course, it's like QPS plus latency. I have it, I have the data there. Like one of the ways that I was able to achieve fast scaling is by building my own metrics pipeline. Like the pods kind of communicate directly with the autoscaler because it needs to be fast. I have latency. I wanted to add QPS and latency both as an alternative strategy. I was just kind of also waiting to see if anybody asked about it. So, do you want it? Okay.
One more.
So cold start time, like from zero. Right now, without a network mesh, it's about 4 seconds, which is too long. And we know it's too long because really, if you're going to rely on serverless to be like fully serverless, you want to know that your code is just going to come back. I think IBM is starting to spearhead some work to get sub-second scaling. I know it's possible. It's just a matter of sort of teasing things apart in a way that is going to be sane. Yeah.
Some of that solution might also come from outside of Knative. There's infrastructure ways that we can address that initially, maybe combine it with capabilities in Knative.
Actually, Greg sitting right next to you knows a lot about that.
Yeah.
You guys should chat.
There was a question over there, sorry.
Yes? Hey, let me come to you. I can't quite hear. What? What about the concurrency? Is there a limit on the concurrency? Oh, that's a good question. So the autoscaler sets a target, right? And it sort of tries to achieve that, but it might not. There is another place where concurrency is referenced, which is in the revision spec, and it gets propagated to the pod autoscaler spec. That says container concurrency. That's the actual limit of what your container can handle. We enforce that. So you can enforce a concurrency limit. And if you don't specify a target, we will base our default target on that value because, of course, it sounds like concurrency is important. So there is the ability to limit concurrency. We want this to work work for apps, but also for like single-threaded functions as well. Does that answer your question?
I think we might be running out of time, sorry. Did you have one more question?
Okay.
Sorry.
Yes, actually, Knative relies on Istio. An integral part of the scale to zero is being able to switch Istio routes between the running revision and a catching service called the activator, which proxies those and bootstraps them. So yes, you can definitely use it with Istio.
If you follow the instructions in a GitHub repository, we'll install Knative and Istio together. And if you go through the GKE add-on, it will automatically be added for you, so you don't have to even ask for it.
Cool. Yeah, I think we're out of time, but I'd love to chat. If you have more questions, I'll be out in the hallway. We still have 5 minutes? Okay.
Apparently we have more time. I don't know how that happened. We always practiced it. It always lasted longer than that.
They put us.
Which does subdomaining rather than path-based things.
I like that answer. Istio will do it for you.
And there's documentation in Knative docs about how to do that path-based routing.
Okay, so I see another question over here.
By the way, this is amazing. People staying after a session and still asking questions. This is awesome.
Are there any thoughts about scaling down nodes as well?
Scaling down. So one thing I didn't talk about at all was scaling up and down nodes, and that actually is very highly dependent on your cloud provider. So right now, the way that those signals get to the cluster autoscaling is just by scheduling or unscheduling or deleting pods. So Knative doesn't really help you with scaling your nodes.
On GKE, if you scale your pods exponentially and nodes will be unused, eventually GKE if you have configured this way, will remove those nodes, but it's not happening very fast.
It's an option.
That's an option.
Yeah. It's on by default, isn't it? Is it not?
It's off by default.
Okay, well, every time I set up a GKE cluster, I tell it to auto-scale my nodes, and it's pretty good.
I think autoscales the question by default.
If you, a system someone using Istio underneath, can you use the same instance of Istio for purposes outside of Kubernetes?
Yes, the answer is depends, but technically yes. The challenge we would probably see is the versioning. So if you're deploying Knative with all the dependency, we will make sure that the right version of Istio is configured. So assuming all these variables were met, technically yes, but to be honest, I don't think we have done a lot of that kind of validation yet.
Like oh, go ahead.
Yeah, there's also, depending how your Istio was configured, if you've configured some certain outbound traffic rules or something, Knative might not be able to live in that kind of environment.
So you tend to dedicate a cluster to it.
Do you dedicate?
Right now there's the recommended process, yes, deploy cluster per instance. This is 0.2 version. Within the GKE add-on, we are trying to, because we have a little more control, we know how it's going to be deployed and run. We're trying to address those kind of concerns. How do you upgrade the cluster after the fact? How do you scale up and down? How do you address some of the traffic shaping and all that? But none of that is right now in there.
One other thing I was going to say on the Istio question. In 0.2, we deploy our own copy of the gateway, but I think in 0.3, that's switching to use the shared gateway. What?
We're going to do
Both, okay. For a release, right.
Just-in-time design.
Because we don't want to break up people running 0.2 when we go to 0.3.
Yeah.
All right. Thank you very much for staying. Sorry. Just come on over.